So this is the first video of Unit 7, which is still graphing quadratic functions and talking a little more about quadratics. However, we're now going to look specifically into standard form and get away from factor form. So your objective is that you can graph a quadratic function in standard form, and then you can state how to find the vertex and axis symmetry from the equation in standard form. So this right here is going to play off the activity we did in class. If you're watching this video before we've done the activity, I'm going to be pulling a lot of information from there, so it may not make sense, but if you look back after we do the activity, be like, oh, okay, that's what Mrs. Seyfried was talking about. So first, from last unit, everything factored when we had standard form, which is right here. The ax squared plus bx plus c. So when it factored, it looked like this: x minus p, x minus q. Well, then our x-intercepts ended up being p and q. So then from there we were able to find our axis of symmetry, which was just finding the average of those two values, find the middle between them. From there we were able to get our vertex by plugging in x into this spot, and then we were able to calculate out our y. And then to only get our y-intercept, we had to plug in 0 and then calculate y. And then to find one more point, we picked one value of x that was really close and then figured it out. And then we were able to reflect that point over. So that was all Unit 6. Well, what happens in Unit 7, so right here, this is Unit 7, it doesn't factor. So to do that, we need to pull from what we came about in the activity. So we were able to find, using that exploration that we did with finding the different values, the axis of symmetry, and we came up with a formula in class. Now the proper formula that you see in books and textbooks is negative b over 2a. However, more than likely this is not the one we came up with class. Most students, when they figure out the formula, will say, well, it's b divided by a divided by negative 2. You can use whichever formula that you want. It doesn't matter to me. To get the vertex, just like before, we take whatever value we get for here, like say we got 3, that is our x value, and then we figure out our y by plugging it in to our original equation. Also from the activity, we learned something very interesting about the y-intercept when it's in standard form. It always turned out to be 0, c. Now, this only happens in standard form that we have the c, that the y-intercept is going to be 0c. It does not happen in factor form because we don't recognize our c. And then to find one more point, we just find an x value close to what we were given, and then y. One thing I also should note with our graphs for this one, last unit we had to do 7 points. This unit, I am happy with 5. So you're now required only to do 5 points on your parabolas. One other thing we discovered from the activity is with the role of A. And it found out the role of A was actually the same as Unit 6. Both A's are the same. So if A is positive, it opens up. If A is negative, it opens down. A also affects the wideness of our parabola. So if A is far from 0, we have a very narrow parabola, either opening up or down, and that depends if it's positive or negative. Or if it's close to 0, the parabola is going to be wide. Alright, so let's do our first example of graphing this equation. So if you're not used to it, let's write out what our A, B, and C is. Where A is 1, A is always next to x squared, B is 6, C is 5. So looking at this, since A is 1, I know it's going to open up. I can find my y-intercept. It's always 0c, so in this case my y-intercept is 0, 5. So to find the axis of symmetry, we're going to use our formula. So I'm going to do the negative b over 2a. Again, you could do b divided by a divided by negative 2. It doesn't matter. So I have negative 6 over 2 times 1. Well, that's negative 6 divided by 2 is negative 3. So my axis of symmetry is x equals negative 3. And again, it has to be x equals. So to get your vertex, the x-coordinate is going to be negative 3. So then I need to substitute in for x and get my y value, or in this case, what f of x is. F of x, again, reminder, is just y. So I go negative 3 squared plus 6 times negative 3 plus 5. All right, so take this into pieces. Don't try to calculate all at once or type in your calculator. That's where mistakes are made. Really take it step by step. So negative 3 squared is negative 3 times negative 3, which is 9, not negative 9, minus 18 plus 5. Then I can figure this out. 9 minus 18 is negative 9 plus 5 gives me negative 4. All right, so filling out my table, we know we have 0, 5, and we have our vertex, negative 3, negative 4. All right. So I'm going to graph, draw my axes on here, straight as I can. It's hard on my tablet. All right, so then I'm going to plot my points. So I have my axis of symmetry, which is at negative 3. I'm still going to do my dashed lines. So I remember that this is the middle of my grid. All right, so then I have negative 3, negative 4. And I have the point 0, 5. And then I just reflect that point over. So I need some other point. So just like last chapter, we just find some other x value we haven't used. I'm going to do negative 2. So plugging in, I go negative 2 squared plus 6 times negative 2 plus 5. Negative 2 squared is 4. Notice I'm doing it again in parts to make sure I don't make a mistake. 4 minus 12 is negative 8 plus 3 is negative 3. Plot my last points. I only need 5 points, not 7 like last unit. If you want to do 7, go right ahead, but I'm only requiring 5. And there's my parabola. Alright, so let's take a look at this one. This one's going to open up because my A is 1, my B is 2, and my C is negative 15. My y-intercept, 0, C, so 0, negative 15. Remember, this is C. Finding my axis of symmetry. I'm going to go negative b over 2a, so negative 2 times 1 gives me negative 1. My vertex is going to be at negative 1, and then I plug in my negative 1 in for x, so I get negative 1 squared plus 2 times negative 1 minus 15. So you get 1 minus 2 minus 15. Negative 1 minus 15 is negative 16. Let's do my table of values. I know I have 0, negative 15, negative 1, negative 16. And I'm noticing as I'm doing this that my numbers are a little bigger, which tells me I'm more than likely going to have to change my scale. Okay, so drawing my grid lines. Alright, so I'm going to go by 2s to make sure it all fits. And then my axis of symmetry I'm going to draw in there. It's right at negative 1. There's my middle, my parabola, my line of symmetry. So plotting my points, negative 1, 16, so 2, 4, 6, 8, 10, 12, 14, 16. Negative 15, 0 would be here, reflected over. Alright, so I need one more point. Looks like 1 is my next best option. So I have 1 squared plus 2 times 1 minus 15. It's 1 plus 2 minus 15 gives me negative 12. 2, 4, 6, 8, 10, 12. And reflect it over. I'm done. I have my 5 points. And there you go. So taking a look at this one now, some of you guys might be like, oh, we need a factorial of GCF. With standard form, we don't need to worry about any of that. We can just go right into finding our A, our B, and our C. If you're solving by factoring or graphing by the factor form, then you would, but don't have to worry about that here. This is going to open down. My y-intercept is 0, 20. My axis of symmetry is negative 8 divided by 2 times negative 2. Negative makes it positive. This gives me x equals negative 2. Find my vertex. It's going to be at negative 2. So plugging in, I get negative 2 times negative 2 squared minus 8 times negative 2 plus 20. Negative 2 squared is 4 minus 8 plus 16 plus 20. That's 8 plus 20 is 28. In my table of values, negative 2, 28 as my vertex. 0, 20. Draw my axes. Oh, that one's terrible. Oh, we'll survive. Alright, so find my middle along my crooked y-axis. Alright, again, I notice I have a lot of ground to cover. So in this one, I'm actually going to go by 3s because I need to go all the way up to 28. Change my color here. So 28, so I go 2, 4, 6, or 3, 6, 9, 12, 15, 18, 21, 24, 27, 28. And then I go 2, 4, or 3, 6, 9, 12, 15, 18, 20 would be here. Reflect it over. Alright, so it looks like I'm missing my negative 1 value. Because x is 0 and x is negative 2. So plugging in negative 1, I go negative 2 times negative 1 squared minus 8 times negative 1 plus 20. Negative 1 squared is 1, so negative 2. Negative 8 times negative 1 is 8 plus 20. That gives me 6 plus 20 is 26. So go 3, 6, 9, 12, 15, 18, 21, 24, 26. And there you go. My 5 points for my parabola. One last one. So you have your A, your B, and C. This might be a good time to pause the video and try to do this one on your own and see if you understand it completely. And if you're able to graph on your own, then you are set for the lesson tomorrow in class. So this one opens down. The y-intercept is 0, 5. The axis of symmetry, we have negative 2 over 2 times negative 1. That gives me an axis of symmetry at 1. My vertex is 1. So we go 1 squared plus 2 times 1 plus 5. So you have negative 1 because 1 squared and then the negative's on the outside. Plus 2 plus 5. 1 is 6. Alright, 1, 6, 0, 5. Drawing my lines. Alright, so my axis of symmetry. It's at 1. Alright, 1, 6, 1, 2, 3, 4, 5, 6. I'm not going to have to change my scale because I have pretty small numbers. 0, 5. Alright, looking, I don't have any points in between, so I'm going to go out 1. I'm going to go to 2. Negative 2 squared plus 2 times 2 plus 5. 2 squared is 4, so that's negative 4 plus 4 plus 5. Oh, you know what? I wasn't paying much attention. I shouldn't have did 2. I already have 2. Sometimes that happens. I just got to pick another one. So let's do 3. Do that over here. So I go negative 3 squared plus 2 times 3 plus 5. Again, the negatives on the outside is not included with the 3, so I go 3 squared, which is negative 9, plus 6 plus 5 gives me 3, 2. Right, and there's my parabola, and it makes sense. It's opening down. It's pretty standard. All right, so just to review, remember your axis symmetry. And again, if you want to use b divided by a divided by negative 2, go ahead, whichever one's easier. I just stay consistent with that. When you graph, you need 5 points. And keep this in mind for your homework tomorrow or your work tomorrow in class. You don't always have to graph the y-intercept. You just then need 2 more points. Sometimes the y-intercept is far away from the axis symmetry and doesn't make sense to use it. So you don't have to use it. Just a reminder to do your reflection so you get credit for watching this video.